Hello, everyone. My name is Daniel Gobriel, and today we'll be talking about database indexing and compression. The presentation objective is basically understanding and breaking down database indexing and compression. We'll be going over what they both are, what both techniques do, how they can better database storage and database speed, and the advantages and disadvantages of the two. So first we'll start talking about database indexing, and then we'll go into compression after we explain database indexing. So what is database indexing? So database indexing is basically a method that helps the database use less disks whenever finding certain pieces of data by using indexes. So what that means is an index is created through the technique that takes you directly to exactly what you're looking for instead of looking through all the data to find what you need. So this helps the database work a lot quicker because it directly goes to what you're looking for instead of, like I said, going through all the information that is stored in the database to find what you need, which ultimately creates more efficient ways of searching. So why is database indexing used? Database indexing is used for effective searching. Indexes quickly help you find what you are looking for when a query is input. So it takes less time to process information with indexes. So like I said, indexing, helps take you directly to what you're looking for, helps pinpoint the database to go to a specific index to find exactly what it needs instead of going through all the data, which ultimately helps the database work a lot quicker. So whenever you put in a select query, it comes out a lot quicker when you use a database index. So today we'll talk about the two database indexing methods. We'll talk about just two: clustered index and non-clustered index, and we'll start with clustered index. So database index method number one, clustered. So a clustered index is basically a way the data is organized. It's basically one key value that stores many records that relate to it. So basically, let's just say you have several departments and each department has different employees. So you try to find a specific employee. So a database method that's not a database that's not clustered, data in a database that's not clustered, tables that aren't clustered. Basically, whenever you search the database, you're going to have to go through all the data. But whenever something is clustered and you input the information, the employee information you need, it takes you directly to the department and only searches that department instead of searching the whole entire database. So what are the advantages and disadvantages of a clustered database index method? So the advantages include good effective searching of data, searching within the range of the index and not all the data. So what that means is it doesn't, use like every piece of data necessary to find what you're looking for. It goes through exactly what it needs to go through to quickly and efficiently find what you need. The disadvantages include slower inserts, update, delete, and delete processes for the DBMS. So basically, as you use, the more indexes you use, the more clustered indexes you use, for each table, the slower the insert, update, and delete processes work in the DBMS. And another disadvantage is basically you can only have one clustered index per table. So that is a disadvantage because it's only one and you can't have many in there that actually even go in and break down the data even more. So the second method, non-clustered. A non-clustered index is a separate file that tells you where the data is located. It basically gives you a reference to where the data is stored. So it's kind of like an index in a book. It doesn't take you to the data you're looking for, but it helps pinpoint you where to look. So it's basically a big old reference that you look through that tells you where to look if you are looking for a specific piece of data. And you can have more than one non-clustered index, which is an advantage per table. So that way you could look through several and really find exactly what you're looking for. So So the advantages and disadvantages of a non-clustered index method include so the advantages include fast data retrieval from a table, and a table can have many non-clustered indexes. So having that index there, that non-clustered index there, helps you in a way find what you're looking for because it's simply there and it helps point you out exactly where to look. The disadvantages include doesn't find exactly what you need in a quick manner. You still have to look through that index to find what you need. And the process can take a little longer because first you'll have to go through that whole index, find what you need, and then you'll be led to where to look to find exactly what you're looking for. Types of database indexes. So we'll talk about three types today: a bitmap index, dense index, and a sparse index. We'll start with the bitmap index. So bitmaps are known as bit arrays, is a data structure that uses a sequence of bits to store the information. So a bitmap basically helps save memory in the database by storing pieces of data in bitmaps. It's good to use bitmaps when values of variables repeat regularly. For example, if you have a relationship column where the attributes are true or false, it's good to use a bitmap because you can store a true that controls the rest of everything into one bit array instead of having several trues and several falses. That ultimately takes up a lot of memory. When there is like I said, when there's low cardinality, it's really good to use the bitmap index. So another one is a dense index. So a dense index, you have a row ID for every entry in the data file. All the keys in data files are linked by pointers to the record. So as you can see, a data file has an index record for every value in the data file. There is an index record. So another type is a sparse index. So a sparse index is used only for certain records. So as you can see in the picture, there is a table with all the sparse indexes, and each index leads you to another table that finds helps you find the data that you're looking for. It finds records that have the largest values of what needs to be found. So it goes through all those values that are very similar to exactly what you're looking for, instead of going through everything else. Advantages of database indexing include more efficient style of searching for records. Indexes help optimize finding records by using a strategic set of sequences that make it easier on the database. Helps speed up the select query because it's going straight to the index and not the heap. And the heap holds a lot of data. The index, holds data pertaining to what you are looking for. So there's going to be like several indexes for several different tables. So whenever you put in a query, it takes you directly to the index instead of going through all the indexes. Instead of going through all the data stored in the database when there aren't any indexes. The disadvantages of database indexing requires additional disk space. So having a lot of indexes take up a lot of space. And a non-clustered index basically does not need as much space as a clustered index. And this kind of slows down application performance. Whenever you use more space, the application doesn't work, the application doesn't work as good as it should. Insert, update, and delete statements don't run as fast. They typically tend to slow down. Now let's talk about database compression. What is database compression? So database compression is basically a technique that helps save memory by either removing redundant data or creating ways that can help store redundant data in bits that ultimately help the database save memory. So why is database compression used? Database compression is used to increase storage capacity by reducing the similar pieces of data that ultimately have the same meaning. So basically, it really either gets rid of redundancies, removes them, deletes them, gets matter there, or finds ways to store them that help the database save memory. It's basically, companies can save a lot of money by not using a lot of storage, buying more storage for the database. This is why database compression is used. How can you achieve database compression? You can achieve it in two ways: by through lossy compression, or through lossless compression. So lossy compression, or better known in my opinion as the delete compression, is basically a technique that goes in and literally, if it finds redundant data, it deletes it, gets it out of there, gets rid of it, basically breaks down the file, which can be good, but on the other hand, it can be bad because it could go in and get rid of needed redundant data and typically destroy a file, and the file will not work as good as it used to. So it's always best to be careful whenever you are using lossy compression. So yeah, use it with caution. Advantages and disadvantages of lossy compression. So it's very, it helps, the advantages include it helps save a lot of memory by, getting rid of redundant data, gets rid of like a lot of unnecessary things. The disadvantages include it can cause a file to lose a lot of quality, get rid of a lot of needed redundant data in that file. So like I said, be careful whenever you're using a lossy compression. Don't use it on something that's a file that's pretty serious or has some serious redundant information. So how can you achieve database compression? Now let's talk through lossless compression. So lossless compression basically finds and stores redundancies in data in bits that can help the database save memory. So it basically repositions the data in a more efficient way without deleting the data. Lossless compression can be achieved. It's achieved using a run length encoding, and run length encoding is basically an algorithm that goes in, finds redundant data, takes all the pieces of redundant data and just keeps them in one piece and uses them when needed. So it doesn't, unlike lossy, redundant lossless goes in and keeps or stores the redundant data in a way that you can use pieces of it instead of just getting rid of it. Advantages and disadvantages of lossless compression. So the advantages include retaining important pieces of data, saving on storage size, and improving data performance. The disadvantages include spending lots of time decoding data to compress it, more storage used than lossy compression. So with the advantages, lossless compression does help retain important pieces of data. It doesn't, like I said, it doesn't go in and delete everything like lossy, but it goes in, finds, everything, finds everything, that's redundant, and basically says, hey, for this file, we have, 10 pieces of redundant data. Instead of, deleting everything, let's take those 10 pieces of redundant data and store them into one bit that can hold those pieces. And if we ever need to go in and use like 3 pieces of the 10 or 5 pieces of the 10, it basically helps you utilize those better than just going in, deleting data like lossy, which is actually pretty extreme. I personally would not use lossy at all. I mean, depending on what the file is, if it's a pretty serious file, don't use it. So yeah, that's how lossless works. It stores the data in better ways that helps you save storage. So the disadvantages include spending lots of time decoding data to compress it. So lossy does take up a lot of time. It basically goes in, goes through all the data, finds the redundant data, and then finds ways to store it. And basically it also uses more storage than lossy compressing, because like I said, lossy compression, it goes in, gets rid of the redundant data, and that's it. In conclusion, database indexing and database compression are ways that help benefit both databases and the people using databases. It helps you, databases work a lot quicker, and it helps them save a lot more memory. And there are many ways you can go about using database indexing and compression methods that best fit your organization's needs. So thank you to everyone for listening to my presentation. I wish you guys nothing but the best. And I hope you did a lot of learning from my presentation. And I wish you guys a great rest of your semester.